Hello students, welcome to this session of structure of atom. In this session we'll be discussing about the neutrons, about the characteristics of neutrons, and we'll also discuss about the Thomson model of atom and the Rutherford model of atom, that is the structure of atom. See, Thomson proposed the model of atom wherein the electrons and protons, how they are arranged. He told about that. So that is the Thomson model of atom. And we'll be also discussing about the Rutherford's model of structure of atom. So let's start our session here. So neutron was discovered by James Chadwick in 1932. See, the discovery of neutron was late. Protons and electrons were discovered earlier, but the neutrons discovery was too late. The reason for the late discovery of neutrons was its neutral nature. See, what happens, how these protons and electrons were discovered? It was nothing. An electric current was passed through the discharge tube and the rays are produced. The streams of minute particles are produced. They were either deflected towards the negative charge or the positive charge in the electric field, and they produce a glow on the opposite side. But these neutrons, they are neutral in nature. So that is why the discovery of these particles was late. Now it was discovered by James Chadwick. And how? There is, say, this is a beryllium rod. This is a polonium. Polonium is alpha particle source, that is, it is radioactive and it produces the alpha particle. Alpha particle is the helium nucleus. Helium nucleus means it has got 2 protons and 2 neutrons. That's it. So He2 plus is the alpha particle. He2 plus is the alpha particle. Now these alpha particles are produced by this radioactive source. Now when they strike beryllium, neutrons are ejected out. See, alpha rays or alpha particles, when they strike beryllium, they eject the neutrons and the protons. Now these neutrons, they will pass through the paraffin and the protons also, right? So the protons, they produce some ionization in this ionization chamber. These protons and neutrons, they both. So the neutrons were discovered by using the beryllium. Do remember this. And neutrons are the neutral particles. Neutron is a neutral particle found in the nucleus of an atom. Why these? These alpha particles, they penetrate the atom of beryllium and they eject neutrons from here. Now these neutrons, they are neutral particles. The subatomic particle, this subatomic particle is not present in hydrogen atom. See, neutron is not present in hydrogen atom. In hydrogen atom there is 1 electron and 1 proton. How the discharge tube, that is the canal rays, were discovered? See, by taking hydrogen gas in the discharge tube. Now they didn't produce any neutron there. And neutron causes the, say, only the protons were produced by the hydrogen. Now this particle is not present in the hydrogen atom. See, this neutron is slightly heavier than proton. That is, it is just 0.18% heavier than proton. Now the mass of neutron was calculated to be 1.675 into 10 to the power minus 27 grams. And mass of proton is 1.673 into 10 to the power minus 27. This is kg, not grams, kg. So the neutron is slightly heavier than proton, that is, it is 0.1% heavier, 18% heavier than the proton. And what is the charge on the neutron? The charge on the neutron is 0. That is, neutron is a neutral particle. So what will be the specific charge of neutron? It is the E by M ratio. So the charge is 0 and mass is 1.675 into 10 to the power minus 27. So the specific charge comes out to be 0. So this is the particle, that is neutron. Now students, do remember, of all the elementary particles present in the atom, what all are the elementary particles present in the atom? The proton, the electron and the neutron. So for all these particles, neutron is the heaviest. Heaviest how? See, proton is heavier than electron and neutron is 0.18% more, or 18% heavier than the proton. So neutron is the heaviest and the least stable particle. So neutron is the heaviest and the least stable particle. It is present in the nucleus. It is absent in the nucleus of the hydrogen atom. So the isolated, if I am say isolating a neutron, so an isolated neutron is unstable and it disintegrates into the electron, a proton and a neutrino. Neutrino is another particle. They were discovered later. So an isolated neutron is unstable and it disintegrates into electron, proton and a neutrino. So in this case, what is neutron? Neutron is a neutral particle found in the nucleus of atom. It is absent in the hydrogen atom. Do remember this. The charge on the neutron is 0. The mass of neutron, the neutron is slightly heavier than proton. That is, it is 0.18% more heavier than proton. Mass of the proton is 1.673 into 10 to the power minus 27 kg, whereas the mass of neutron is 1.675 into 10 to the power minus 27. Proton is 1.673 and neutron is 1.675. So the neutron is heavier than the proton. And remember, neutron is heaviest among all the elementary particles present in the atom, and it is least stable particle. An isolated neutron dissociates or it disintegrates and gives the electron, proton and the neutrino. So an isolated neutron disintegrates and it is least stable. So this is all about the elementary particles present in the atom. Now, how these particles are arranged in an atom? See, proton is a positively charged particle and electron is a negatively charged particle. How they are arranged in the atom? To explain this, various models for the structure of atom was given. The very first model was given by Thomson. Now let's study about the Thomson's model of structure of atom. See, an atom can be depicted by this picture. An atom is composed of protons, neutrons and electrons. Protons and electrons mutually balance their charges. Why so? Because the protons are positively charged and electrons are negatively charged. Say, in an atom, it is a general picture of an atom. There is a nucleus at the center and the electron. So it is proposed that the electrons are orbiting round the nucleus in an elliptical manner. Now this was proposed by Rutherford. So I'm just trying to show you what all elements are, or what all elementary particles are present within the atom and how they are arranged. See, this is the nucleus. If an atom is disintegrated, or if I take up the particles, there is a nucleus and an electron. This is the diameter of electron given, and it is less than 10 to the power minus 16 centimeter. This is the nucleus. This is 10 to the power minus 12 centimeters. It is not minus. Do remember this. Now the neutron again has got the proton and the neutron, the nucleus. The nucleus has got the proton and the neutron, and it is giving the very small particle, that is the quark. Fine. So these are all the particles present within the atom. And let's discuss how they are arranged. And first of all, we'll discuss about the Thomson model of atom. Thomson's model of the atom. When J.J. Thomson proposed his model of the atom in 1903, then only electrons and protons were known to be present in the atom. Say neutrons were discovered in 1932. So when Thomson proposed his model of atom or model of the structure of atom in 1903. At that time, neutrons were not existing. It was not discovered also. So according to him, what all were the elementary particles present? The protons and the electrons. So these were the elementary particles present in 1903 when J.J. Thomson proposed his model of atom. Now what he suggested? Thomson proposed the model of an atom to be similar to that of a Christmas pudding. See, it has got a pudding, the pudding which is made, pudding-like structure. That is, the electrons in the sphere of positive charge as or like dry fruits in this spherical Christmas pudding. Say if it's a pudding over here, then the dry fruits, some cashew nuts, some almonds and raisins, like this. So this pudding, according to the Thomson model, the base is of the positive charge, and the negative charge, they are just scattered or they are present. The electrons in the sphere of positive charge are like the dry fruits in this spherical Christmas pudding. Let's see the diagram of what he proposed. An atom consists of a sphere or ball of positive charge with negatively charged electrons embedded in it. It's just like he suggested that it is like a pudding with a sphere of the positive charge and the negatively charged particles scattered in it or embedded in it. The total negative charge of electrons is equal to the total positive charge of the sphere. Why so? If it's not like that, the atom won't be neutral and stable. So the total negative charge is equal to the total positive charge. That is why an atom is electrically neutral. See, this is the Thomson model. The shaded area in the sphere contains all the positive charge in the atom. The negatively charged electrons are spread throughout the positive charge. So all the positive charges are in this green area, and the negative charge are embedded in it. So this was the model proposed by Thomson, and he also suggested that the total negative charge is equal to the total positive charge, so that an atom becomes neutral, or atom is neutral. But later, say after 1932, their neutrons were also discovered. Now where are the neutrons present? There is no space in the Thomson model of structure of atom where the neutrons can be fitted in or embedded. So then Rutherford proposed his model. So we'll be discussing about the Rutherford's model now. So Rutherford's model of an atom, that is, Rutherford proposed his model of structure of atom based on his alpha scattering experiment. So this is his alpha scattering experiment. Rutherford's alpha particle scattering experiment led to the discovery of a small positively charged nucleus in the atom containing all the protons and the neutrons. So he did his alpha scattering experiment. You can see over here. So this is the alpha particle emitter. Alpha particle is what? It is a helium nucleus consisting of only the neutrons and the protons. Now alpha particles are emitted. He took a thin gold foil. See, this is a gold foil. And there is a slit over here. The alpha particles produced by this alpha particle emitter, they strike the gold foil and the rays were produced. This is the detecting screen. Now how he deduced this conclusion, or what were his observations? Let's study that. When fast moving alpha particles were allowed to strike a very thin gold foil in vacuum, it was found that, what he did was that he allowed the alpha particles to strike a very thin gold foil, and he found that most of the alpha particles passed straight through the gold foil without any deflection from their original path. Say this is a gold foil taken, suppose, and it was struck by the fast moving alpha particle. So most of it he found to pass out straight. A few alpha particles were deflected through small angles and a few were deflected through large angles. Deflected through small angles means it is like they passed out like this and then they got deflected. Deflected through large angles means striking and getting back. So he adjusted a detecting screen over there, just like this. See, there is a detecting screen. So what he observed, that when these fast moving alpha particles struck the gold foil, few deflected by large angles. See, this has come back. Few deflected by very small angles and some of them passed straight. A very few alpha particles completely rebound on hitting the gold foil and turn back on their path, just as ball rebounds on hitting a hard wall. We can see here. See, this is the alpha particle emitter. It is emitting fast moving alpha particles. These alpha particles are striking the gold foil. Say most of them have rebound. A very few of them, not most of them, few of them have rebound. Few of them have been deflected and some have passed straight. Now why so? Say this gold particle, gold plate I am taking. Now this is composed of gold atoms. So why these alpha rays are showing these three behaviors? That some are passing straight, some are deflected by small angles and some are deflected back, or they have rebound. Why is it so? What is the reason behind it? So he concluded that since most of the alpha particles passed straight through the gold foil without any deflection, it shows that there is a lot of empty space in the atom. Say most of the alpha rays, they passed straight. As they passed straight, it means it is a hollow ball. There is no particle. Now the observations that the alpha particles are deflected through small and large angles show that there is a center of positive charge in the atom. Helium is what? This alpha particle is what? These are He2+, that is the helium nucleus. These are positively charged. Now these are deflected back. Some rays were deflected back, they rebounded. Some of them deflected by the small angles. So it suggests that there is a center of positive charge in the atom which repels the positive charged alpha particles and deflects them from their original path. So the structure of atoms, see the gold is made up of large number of atoms. It is composed of large number of atoms. Now most of the particles, they passed straight, most of them were deflected by small angles and most of them rebound. So what it suggests, that atom has got the lot of empty space through which the particles, they went straight. it has also got the center of positive charge through which the particles they deflected back, and there was slight deflection also. So it can be shown somewhat like this. The space between the atoms is not much. There are many atoms in between. Just to clarify, I have drawn like this. See, the alpha particles, some of them passed straight. Most of them they passed straight. See, that is, the atom has got the empty space from where the alpha particles they pass straight. Some of them they deflected by small angles like this, and some of them they deflected back completely. That is, they striked this nucleus and deflected back, strike the nucleus and deflected back. So Rutherford suggested that atom is an empty structure, or is a structure with a large empty space with a dense nucleus at the center. That is why the rays, most of the rays, they pass straight through it. Some of the rays they got deflected, and the rays which strike the nucleus they deflected back by large angles. They rebound. So this was the model proposed by Rutherford. We'll be discussing it in details. Rutherford's alpha particle scattering experiment shows the presence of a nucleus in the atom. See, alpha particles, they are positively charged particles. Now they rebound completely like this. It means there is some center where the positive charge is concentrated. That as soon as these positive particles hit it, they rebound. Again, nucleus of an atom is very dense and hard. It is dense, otherwise they would not have rebound. Some of the rays would have passed through it. Nucleus of an atom is very small compared to the size of atom as a whole. Why so? Because most of the rays they passed straight. So the nucleus of the atom is very small compared to the size of atom as a whole. Based on his observations, he proposed his model of structure of atom. An atom consists of a positively charged, dense and very small nucleus containing all the protons and neutrons. That is, a very small, dense, positively charged nucleus is there containing all the protons and the neutrons. Now protons, as has been discovered, that the protons are having the positive charge, where the neutrons they are neutral. Almost the entire mass of an atom is concentrated in the nucleus. His next postulate: the nucleus is surrounded by negatively charged electrons. Say, at the center there is a very dense and a heavy nucleus. The entire mass is concentrated over here, and the electrons are around it. Now there are so many electrons. Say, if I am taking up the example of nitrogen, so there is a nucleus of nitrogen where there are 7 neutrons and 7 protons, and there are 7 electrons. Now how are these electrons arranged? Now he suggested that the electrons are revolving round the nucleus in circular paths at very high speed. That is, the electrons, how many electrons are there? 7 electrons. Now these electrons are revolving round the nucleus. It is also called as planetary model. Say, as the planets revolve round the sun, so are the electrons revolving round the nucleus, and that too in circular paths at very high speed. The circular paths of the electrons are called as orbits. Now, why is suggested that they are revolving at very high speeds? See, the reason is, in the center or at the center there are protons. Say in case of nitrogen there are 7 protons. Now if the electrons are static, then what will happen? They will observe a pull inside and they will fall into the nucleus and the atom will collapse. Protons, they are positively charged, so they will be pulling the electrons inside. So an atom will collapse. But it doesn't happen. Atom is stable. So he suggested that the electrons are revolving round the nucleus in circular paths, and that too at very high speeds. Now how are these balanced? Say the nucleus and electron is revolving in the circular path. How is it balanced at its position? How it is fixed at its position? Why not the position of electron is changing? Now for this he proposed that the electron is maintained at its position. Say the circular paths of the electrons are called as orbits. Now the electrons are maintained at its position due to the 2 opposing forces. Say first is the centrifugal force and the second is the centripetal force. Centripetal force. Now centripetal force is due to the force of attraction between the nucleus and the electron, and the centrifugal force is acting outwards. So due to these equal and opposite forces, the electrons maintain the circular path, and as they are moving at very high speeds, the force of attraction, or they are not collapsing into the nucleus. So this was the model proposed by Rutherford for the structure of atom. So here the electrostatic attraction, or this is the electrostatic force of attraction between the positively charged nucleus and negatively charged electrons holds the atom together. So there is the force of attraction. See, the nucleus is over here and these are the electrons. There is a force of attraction between them. But why not the electron is collapsing into the nucleus? Because it is moving or revolving at very high speed, and it is balanced at one position due to the 2 opposite forces, the centripetal force and the centrifugal force. An atom is electrically neutral. Why so? This is because the number of protons and electrons in an atom is equal. Most of the atom is empty space. How he concluded this? Because most of the alpha rays, they passed straight through the atom. So an atom can be represented by this. See, this is the central nucleus and the electrons are revolving around this nucleus at very high speed. Had the speed been less, the electrons would have collapsed, or the electrons would have fallen into the nucleus. Now in this case, the motion, this is a circular motion, and a circular motion there are 2 types of forces acting. The equal and opposite forces there are called as the centripetal force and the centrifugal force. Here the centripetal force is the force of attraction between the nucleus and the electron, and the other is the centrifugal force, which is acting towards outer side. So this was the model of atom proposed by Rutherford. See, if it is an atom, lots of empty spaces are there. through which the alpha particles they passed straight. Alpha particles are positively charged particles. Now those alpha particles which strike the border of the nucleus, they deflected by small angles, but which strike straight to the nucleus, they rebounded. So this he concluded from his alpha scattering experiment, right? So what are the postulates? That an atom is composed of the nucleus which is present at the center, first thing. Secondly, the whole mass of the atom is concentrated in the nucleus. Thirdly, nucleus is very small and is dense. Fourth, most of the atom is empty. And fifth, the electrons are revolving round the nucleus at very high speeds. Had it not been the case, atom would have collapsed. The motion of the nucleus of the electron is balanced by the centripetal and the centrifugal forces. So this is also called as the planetary model of atom, as it is similar to the revolution of the planets around the sun in the solar system. So this is the model proposed by Rutherford. So I hope you have understood this. Now I'll be concluding this session, students. In the next session we'll be discussing about the drawbacks of Rutherford model and the Bohr model proposed by Niels Bohr. That is the model of structure of atom proposed by Niels Bohr. I hope you are enjoying these sessions. So thank you, students. Thank you for listening patiently, and do have a nice time ahead.